Hi everyone, welcome to this video where today we're talking about absolute value inequalities. Now before this lesson, you learned all about compound inequalities. So how to write an inequality or graph an inequality that was an or an and. And remember, or compound inequalities were basically like anything goes. It could be this or it could be that. And so you graphed and shaded in everything that was part of the solutions for either inequality. But and only cares about the overlap. Now, when we're dealing with absolute value inequalities, it's going to be a mix of our compound inequalities, and then also remember how we solved absolute value equations in a previous chapter. So there's a couple things that we're going to have to make sure we know right from the beginning. And the first thing is that when we are dealing, we're going to know rather that the compound inequality, the absolute value inequality, is going to be an and if the inequality starts with a less than. Okay, so if you say less than and less than, anytime an inequality starts with a less than symbol or a less than or equal to symbol, it's always going to be an and compound inequality. And so we take this inequality, the absolute value of x is less than 4, and we write it as two separate statements. It's going to be x is less than 4. Remember, we wrote absolute value equations. The first equation was just the exact equation here, but we dropped the absolute value bars. And then the second equation, we kept it the same, but we made the number at the end opposite sign, negative. That's basically the same thing that's going to be happening here, but we also flip the inequality symbol. So when we take an absolute value inequality, we have set up two separate inequalities. Again, the first inequality, and I'm going to number it here, looks just like the original inequality that's here with no absolute value bars. And the second one, you flip the inequality symbol and you change the number to a negative, okay, or its opposite sign. Now, there's nothing to solve here. It's just the two inequalities. But remember, and means we're able to write it in that special set builder notation where we start with a smaller number. So I'm going to go ahead and start my set builder notation. But I start with the smaller number of my inequality. So instead of saying x is greater than negative 4, I'm going to start with negative 4 and I'm going to reverse the entire statement. Negative 4 is less than x. So this statement is right here. Then we attach the second statement, continuing on with that same x value. So now x is less than 4. This would be the compound inequality statement we would be able to say for this absolute value inequality. The absolute value of x is less than 4. It means that negative 4 is less than x, which is less than positive 4. Then remember what it means to graph. So this would mean I would have an open circle at negative 4, an open circle at positive 4, and then everything shaded in between. Whenever you have a variable in between two numbers, it always means you're shading in between those two sections. So then the same thing's going to happen here. If I say the absolute value of x is less than or equal to 4, because it's less than or equal to, that's going to be an and. So my first inequality is x is less than or equal to 4. My second inequality would be x is greater than or equal to negative 4. So again, in the second inequality, you flip the sign and you flip the inequality sign and you change the sign of the number. So now, same idea. I look at my two values. I start with my smaller number. So negative 4 is less than or equal to x. Remember, you reverse the entire statement. And then you attach this x to the other inequality that you have is less than or equal to 4. Notice this is pretty similar to the previous one, but if there are less than or equal to, it means that there's going to be closed circles at both negative 4 and 4 and everything shaded in between. I have a bunch of problems here for us that we're going to be taking a look at. Some of these also have special solutions, so be on the lookout for that. All right, so absolute value of x plus 1 is less than 4. So my first inequality would be x plus 1 is less than 4. And the second inequality would be x plus 1 is greater than negative 4. Again, you keep what's in the absolute value bars the same, but for the second inequality, you change the symbol and then change the sign of the number. We would go ahead and we would solve each of these individually. Because it is a less than, I know it's going to be an and compound inequality. To put these together, remember, you start with the smaller number. So the smaller number is negative 5. So instead of saying x is greater than negative 5, I would say negative 5 is less than x. So this inequality is really here. And then I attach it onto the other inequality. X is less than 3. And you can see that that is there. Good. Next one. Absolute value of n plus 1 is less than negative 5. So n plus 1 is less than negative 5. N plus 1 is greater than positive 5. I would go ahead and solve. And now think about this. It's an and, right? And I don't want us to be robots and just go with the flow like we did in the previous problem. Can you think of a number that's less than negative 6 and it's also greater than 4? It's impossible. This is actually no solution. And we could actually have figured out that it was no solution right from the beginning, because take a look. The absolute value of anything could never be less than a negative. The absolute value of anything is always positive. There's no positive number in the world that could ever be less than negative 5. So you can actually tell it's no solution right off the bat. Or if you kind of just went with the process, you would look at these numbers and say, you know what, it's an and there's definitely no way I could find a number that meets both requirements. Let's take a look at the next two. All right, so this one here, first thing we do need to do is we always need to get the absolute value bars isolated. So we do need to subtract 1 here first. We would then need to set up our two inequalities. So x minus 2 is less than or equal to 3. And then x minus 2 is greater than or equal to negative 3. All right, so again, notice the x minus 2 I don't change any signs with that. We go ahead and we add 2 on both sides. Pretty good. And then remember, so think about this. There is definitely a solution because I can think of a number that's less than or equal to 5 and is greater than or equal to negative 1. Okay, so we're good to go on here. Again, start your step builder notation. Start with the smaller number, negative 1. So then instead of saying x is greater than or equal to negative 1, I would say negative 1 is less than or equal to x. And then I continue on with the other inequality. X is less than or equal to 5. And then my graph would be closed circles at either 1, a closed circle at negative 1, a closed circle at 5, and everything shaded in between. And actually, now that I mentioned that, I don't think I went down to this graph, so let me just show you. And if it's negative 5 is less than x is less than 3, that would be an open circle at 5, an open circle at 3, and everything shaded in between. Last one here. Absolute value of n minus 2 is less than or equal to negative 6. Now, the absolute value of something, remember, is always positive, and there's no way a positive number is ever going to be less than or equal to negative 6. So since we saw a problem that was similar to that before, that's going to tell us that already there is just simply no solution. And if you have the absolute value of anything ever less than or equal to a negative, that is when it's going to be no solution. It's impossible. Okay, so now we're going to take a look at the other situation where we would have or. Now, you know it's going to be and if it's a less than symbol. And the reason for that is when you're doing less than, you're confined within a certain barrier, a certain restriction, a minimum or a maximum. With or, it could be on the extremes. It could be greater than this number or less than this number. You're kind of going out in either direction. And that always happens with the greater than symbol. And you could say greater as a way to remember. So if you see if you see a greater symbol, it's or. If you see a greater or equal to symbol, it's going to be an or inequality. So my first one here would be x is greater than 4, or x is less than or equal to less than negative 4. So remember, the first inequality you keep, the second inequality, you flip the inequality sign and you change the sign of the number. Or compound inequalities, remember, you just keep separate. There's not going to be any overlap here. You're also not going to have to just write one of the inequalities, because think about it. All the numbers that are greater than 4 or less than negative 4, those are definitely going in opposite directions. And so the same thing would be the case here. X is greater than or equal to 4, or x is less than or equal to negative 4. Completely opposite directions. And in this case, they're just simply closed dots, because 4 or negative 4 can be part of the solution set. Okay, so here's our greater than problem. So here we've got 3 times the absolute value of 2x is greater than 30. We first have to divide by 3. You always need your absolute value expression isolated. Now I can set up my two inequalities. So it's 2x is greater than 10, or 2x is less than negative 10. So again, for the second inequality, you change the sign of your number. We're going to go ahead and solve. Divide both sides by 2. X is greater than 5 or X is less than -5. Those are definitely inequalities that are going in opposite directions. And so my absolute value inequality graph would look like this. All the numbers that are less than -5, rather, all the numbers that are greater than +5. Pretty good. Okay, now look at this. Absolute value of 4x minus 2 is greater than -8. Now the absolute value of anything we always know is positive. Any positive number in the world is going to be greater than -8. Do we agree? So let's see what actually happens here. We have 4x minus 2 is greater than -8. 4x minus 2 is less than +8. Add 2 on both sides. Divide both sides by 4. We have x is greater than -1.5 or x is less than 2.5. And what ends up happening here, guys, is that when you graph both of those, and this is a really ugly graph, all the numbers that are greater than -1.5 and all the numbers that are less than 2.5, it's literally the entire graph. There's overlap and it just extends. And so that's going to be a case, and we could have figured that out right from here. If you have the absolute value of anything ever set greater than a negative, it's always going to be all real numbers. I've got 2 last problems for us here. 2x, absolute value of 2x plus 3 is greater than or equal to 1. So 2x plus 3 is greater than or equal to 1, or 2x plus 3 is less than or equal to -1. We would go ahead and solve, subtract 3 on both sides, divide both sides by 2. Okay, it's or. So we're just going to write them separately. All the numbers that are less than or equal to -2, all the numbers that are greater than or equal to -1. And this is what my graph would look like, okay, for that compound inequality for or. And then my last one, absolute value of x minus 7 is greater than or equal to -5. Absolute value of any number in the world will always be positive, and any positive number is always going to be greater than -5. But if I went ahead and I solved this, and again, it's or, and I went ahead and I graphed it, I'm going to notice the entire number line is shaded in, and that's how I know it's all real numbers. I have a couple more problems here for you. I'm going to strongly suggest that you pause after I show the problem, do the workout on your piece of paper or your dry erase board, and then press play in between each one. Okay, so go ahead. Try the first one, and press pause and play when you're ready. Okay, hopefully you're ready. Here is what your 2 inequalities should look like. Because it's less than, it's an and, okay? And then because it's less than, here is what it would look like as an and statement. -9 is less than or equal to n is less than or equal to 15. Here is what my graph would look like. Closed circle at -9, closed circle at 15, and everything shaded in between. Go ahead, try number 2. Okay, hopefully you have finished this one before you're watching this now. It's greater, so it's going to be an or compound inequality. I go ahead and I solve both. I can write it in step builder notation. I leave or in between. And then I can see when I go to graph it, they're in opposite directions. And then our last one. So give this one a shot and then press play when you're ready. Okay, hopefully you did the problem. It's greater or equal, so I know this is going to be an or inequality. I set up my 2 separate inequalities. We do our solving. Because it's or, they're going in opposite directions here, and that would be what my graph would look like. Hopefully this video was helpful for you. Thank you so much for watching. Bye.